Yeah. Previously, we here, right? So this guy is your editor. Is your editor is where you're gonna write all your code. But before I actually get there, I wanna talk about a few things before we actually, get into um, serious things. So I will simply going to clear the console. So Scilab is like your calculator. It it is not different from your calculator when it comes to addition and subtraction and division. So it uses a star to multiply. It uses a backslash to divide. Um, it uses a dash to minus. That's just it. But what makes Scilab different from a computer, from a calculator, is that it can handle matrices. But let's talk about numbers. So if I say 5 plus 5, I get a 10. Uh, and it stores it in the variable answer, which is there now, like I told you. So if I divide 5 over 7, I still get an answer. If I multiply, so it's not different from your calculator. If I want to take to the power, I can simply do this 8 double star 2. It simply takes it to the power. Or I can use the cap sign. 8 to the 2 to still do it. So whatever you prefer, it will work like that. But it's a numerical tool, so it doesn't understand numbers, words. It doesn't understand strings or like words. So you can only store numbers in your words. You cannot store words in your numbers. So like it's a it's a numerical processing tool. It works with numbers. It understands the numbers better. If I want to write a matrix, let's say 1, 2, I use semicolon to split um, rows. I use a space. You can use a space or a comma to separate to create columns. A semicolon to create rows. So that's our A there. So you can see that all of these things are stored in a variable answer. But what actually pops up when I write the answer? The latest one. So this is how Scilab works. It will always store your variables according to the latest one. So for example, I wanna store 7 in A. So my A is 5 then. But then so whenever I want A, it will always pop up 5. So I've stored A into 5. Let me clear it again. F2 is to clear the whole thing. Or you can simply type CLC. So whenever I write A in my console, it will pop up 5. But let's say I now say A is equals to 9. What happens is it stores it in 9 now. So when I call A, it no longer gives 5, it gives 9, because it works in a down the ladder way. So the latest guy will be the last guy you've computed. So that's how it works. It works with matrices nicely. So you remember I had that matrix, so let me just make a matrix. 1 2 4 6. I hope it has, this is the matrix. If I want the inverse of this matrix, I can simply say 1 backslash 1. It gives me an inverse. What's nice about a backslash is because even if a matrix is singular, it will compute a value. Or you can simply write inverse of A. Inv is just a built-in function, so it gives the same thing. I mean, even the forward slash will still give you the same thing again. Or even A to the minus will still give you the same thing. So whatever you use, but I will suggest you use backslash, because backslash will work in situations that will not work at all. So for example, let me call b is equals to 1 2 2 4. We know there's this matrix doesn't have an inverse, so if I write something like inverse b, it will say it is singular, right? Same for others, but if I write b backslash 1, it will still compute. Our matrix is close to singular, badly scaled, whatever, computing the least square solution, so it will still compute. So there it is. It has computed something. It has something. Even though the matrix is singular. So this is a least square. Like Scilab has these nice powerful tools embedded in them and all that. So this is basically your run around introduction of the second lab. This is just how you follow. This is how you do it. No biggie. Nothing.